Hi everybody, this is Unit 1, Lesson 6, Linear Modeling. The objective is students will turn descriptions of situations into linear equations and solve them. So the two big things to remember, the two big formulas that you're going to see most of the time is that distance equals rate times time plus whatever the initial distance was, and the total cost of anything is going to equal the cost per unit times the number of units plus the initial cost. Now those are the same equation if you think about it, whereas the cost is the same as the distance, then the rate is the cost per unit, and the initial cost is the same as the initial distance. So if you can just remember the distance equals rate times time plus initial distance, you'll be able to solve any linear model. So here's an example. Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises at 50 feet per minute. Write an equation to model the balloon's elevation as a function of time. How long will it take the balloon to reach 412 feet? So this is a two-part question. First, it asks you to write an equation to model the balloon's elevation as a function of time. Remember, we use that function, so this is going to be an f of t because it's a function of time. And how long will it take the balloon to reach 412 feet? So it's two parts. You need the equation and the time it will take to reach 412 feet. So like I said, the only thing you got to remember is distance equals rate times time plus initial distance. But this doesn't ask about distance, it asks about elevation. And another word I can use for elevation is height. So it's the same formula. The height equals the rate times the time plus the initial height. In this case, we're trying to find the height, the elevation, as a function of time. So that's a variable. T is a variable, the time. The rate is 50 feet per minute. And the initial height is 12 feet. So the equation we get here is h equals 50t plus 12. Now the second part asks us to find the time when the height will equal 412 feet. So we take that formula we just found in the first part, we plug in 412, that gives us 412 equals 50t plus 12. We subtract 12 from both sides, gives us 400 equals 50t, divide by 50, and that gives us the t equals 8. But that in a word problem, that's not good enough, because I need to know 8 what? Is it 8 minutes, 8 seconds, 8 miles, 8 kilometers, 8 grams? I don't know if you don't tell me. So the answer here, because it was 50 feet per minute, it's 8 minutes. That's the unit of time we were using. Now when you see these drawn on a graph, remember this is just the same representation as a function, only instead of an equation we have it as a line. The most important number we want to focus on when we see this is the rate of change. Remember, because distance equals rate times time. Without the rate, we don't really know much. Now the way you measure the rate is to take the change in y, or the rise, divided by the change in x, or the run. And when you do that, it's going to tell you for every x that I go over, the y rises by this amount. So in this case, where I take any 2 points that are on there, it's negative 2, 2, and 4, 1. Okay? I subtract the y's to find the difference in the y's. How far did the rise go? So negative 1 minus 2 is 3, and negative 4 minus negative 2 is 6. You can also do that by counting. That line from the left to right goes up 2 and over 6. So you take the difference in the y divided by the difference in the x, and that's 3 over 6, which is 1/2. And you can see this in the graph if you look at it. If you look at 0, negative 1, if x goes over to 1, it has gone up by 1/2. So that's what the rate of change is going to tell you. We use the variable rate m to represent rate of change. Now to generalize, this is a formula, but if you remember how we found that formula and what we were doing, you don't need to memorize this formula. But if you wanted to have it for your records, I'm going to put it on the screen now. Whereas if you have any 2 points, x1, y1, and x2, y2, to find the rate of change, you do y2 minus y1 divided by x2 minus x1. But again, the rate of change is the difference in y divided by the difference in x. Forget that. There are certain things I know. If I know that the line goes up if I move from left to right, then the rate of change is positive. I know if the line goes down from left to right, then the rate of change is going to be negative, because the difference in y is going to be a negative number. If the line goes horizontal, then there's no rate of change. If x goes over by 1, y goes up by 0, so there's no rate of change. And I know if it's vertical, then there's undefined, because remember, rate of change is if x goes over by 1, how far does y go up? And in this case, if x goes over by 1, y no longer exists, so it's undefined. and that's not a function. Vertical rate of change messes everything up. So this is a formula called point slope form, and if you know the slope of a line, slope is a different name for rate of change. If you know the rate of change of a line for m, and you know one of the points, you can plug this into the formula and then get y by itself to come up with an equation. It works like that. I'm going to find the equation of this line using that point slope form that I just showed you on the last page. So I need to find 2 points in order to find the rate of change. One point is -3, 2, and another point is 2, -2. It's always easiest to pick points that have integers for their coordinates. So in this case, I need to do the y2 minus y1, which is -2 minus 2, and the x2 minus x1. Oh, I did it the other way. And it doesn't matter which point you call y1, which point you call y2. So in this case, I call the top point y2 and the bottom point y1, if you're following the formula. But it still works out the same way. I'm finding the difference in y's and the difference in x's. So 2 minus -2 is 4, and 3 minus 2 is -3 minus 2 is -5. So the rate of change is -4 over 5. And I'm going to take the point -2, -2. So it's y minus y1, which in this case is -2. So it's y minus -2, which is y plus 2, equals -4/5 over x minus 2. Now I wanted to make sure I showed you that because you can't get through a math class without seeing point slope form, but I'm not a huge fan of using it. I'm going to use a different method, and you'll see it's kind of figuring out what the answer has to be. So if I have a candle that is 6 inches tall after burning for 1 hour, and after 3 hours it's 5.5 inches tall, I need a linear equation modeling the height y of the candle after burning for x hours. So x is going to be the time, y is going to be the height. And we do this. Distance equals rate times time plus initial distance. Same thing, right? Rate times time plus initial distance. Only again, I'm at height, so I'm going to say height equals rate times time plus initial height. Now, unfortunately for here, we don't know any of these things right now. We know the height after a certain time. We know the height after 2 different times. We don't know the rate, and we don't know the initial height, because the first thing it tells us is after 1 hour, which is not the initial height. So we're going to have to find everything. The easiest thing to find is the rate. Okay? And we do know that 8y is the height and x is the time, so we can rewrite it like this. So we need to find the rate. So we find the difference in y, which is height, divided by the difference in x, which is time. So in this case, it's 6 minus 5.5, and it's 3 minus 1, because that's the difference in the height and the difference in the time. And I know that the answer is going to be negative because the candle is getting shorter, not taller. So the height is going to go down as time goes up, which means the line is going to point down, which means the rate of change is going to be negative. So when I do 6 minus 5.5, I get 0.5. I do 3 minus 1, I get 2. So negative 0.5 over 2. When I do 0.5 over 2, I get negative 0.25, which is negative 1/4. So the rate of change for this problem is negative 1/4. So I know that y equals negative 1/4 plus some initial height. 1/4 x, I'm sorry. But I also know that after the candle is 6 inches tall after 1 hour. So I know after when x is 1 hour is the time, y is 6, because 6 is the height. So I can plug those in. I know that that has to work because it's been told to me in the problem. So 6 equals negative 1/4 times 1 plus the initial height. That means when I add 1/4 to both sides, because 1/4 times 1 is negative 1/4, I add 1/4 to both sides, and I know the initial height is 6 1/4, right? But I already knew from the first thing I wrote that y equals 1/4 x plus initial height, and I know the initial height is 6 1/4 now, so y equals negative 1/4 x plus 6 1/4. Okay, on your homework, there's a couple of different things. Some of these ask you to set up not equations, but inequalities. So it's the same thing, only you have to figure out whether you need a greater than, or equal to, less than or equal to, or an equal sign. Okay, I'm going to let you try to figure that out on your own. So good luck on the homework, and I'll see you in class next time for our study guide.